and welcome to this PV Magazine webinar, in which we will learn about the latest utility-scale PV technology trends in Europe, with a focus on string inverter market developments and the changing equation for their levelized cost of energy. My name is Maria Maish. I'm an editor at PV Magazine Global, and joining me today in the moderation of this webinar is my dear colleague, Mark Hutchins.
Thanks, Maria, and hello and welcome to our audience. Thank you very much for joining us today. Coming up in this very special PV Magazine webinar, we are getting into the technical detail of developing and operating large-scale solar projects with insights from both inverter and module suppliers and the EPC, that's engineering, procurement and construction suppliers, that turn these and a wealth of other components into a working PV power plant. A couple of great presentations on the way to you this afternoon, and then in the second half of the program we have what is sure to be a very informative panel discussion focusing on the value proposition of a few different string inverter technologies.
But before we kick things off, a little housekeeping. We want you to get involved today and use your chance to tap on our guests' expertise. So please don't hesitate to send any question or comment you might have through the Q&A tab and join the discussion, and we'll endeavor to get to as many of them as possible. One question that we often hear from you is, will the slides be available afterwards? Well, the answer is yes. All registrants for today's webinar will be receiving an email from the Big Marker webinar portal with a link to the recording, which can be further shared with friends and colleagues. And of course, the PV Magazine webinar team is standing by to answer any questions you might have about the Big Marker platform or any other administrative matter.
Well, we have a lot of great speakers and discussions to get through today, so let's not waste any time and get underway. Introducing, first of all, our partner in producing this webinar, which is GoodWe, an inverter supplier that has seen rapid growth in recent years, placing it very much in the big leagues of inverter supply. And kicking off the presentations for today is Alvaro Zanón, GoodWe's technical director for EMEA in the utility and large-scale sector. Alvaro has worked on string inverters for more than 12 years, both in Europe and the US markets, making him an early believer in this technology. And he joined GoodWe following a lot of positive feedback from customers. Alvaro is here today to share the market perspective of a major inverter supplier. Alvaro, a warm welcome. Great to have you with us today, and over to you.
Thank you very much, Mark. Well, first of all, good morning, good afternoon, good evening. Depending on which part of the world you are connecting from. Of course, this is a global event. First of all, on behalf of GoodWe and PV Magazine, we would like to thank each and every one of you for joining us today in this annual GoodWeek event. My name is Alvaro Zanón, and I am the Technical Director for EMEA, for utility projects in GoodWe. And today's event will be focused on utility scale solutions, taking a closer look at the progress and market trends with string inverters. Last year, 2022, I must say, it was a fantastic year for GoodWe in the utility segment, surpassing all the expectations, both internal and external, winning milestone projects in very important key markets, and creating strong relationships with the top customers. So, thinking back, how were we able to achieve this success? Of course, I don't have the formula. There is no one-size-fits-all formula for this, let's say. But in my opinion, there are three main pillars to the success. First of all, of course, is the product. If you don't have a good and reliable product, you will be out of the market in no time. But also, it's very important that your product will be able to provide some features and advantages that your customers cannot find in other inverter suppliers, and that will help them win the project. In today's event, one of my colleagues will be giving a presentation on our products, so you will get to see which are these benefits that I've been talking about. The second pillar of success is the team. Very important to have a dedicated and experienced team who understand the needs of the market and the customers, who can also push for the internal resources to take the project to execution, to success, and who is also resolutive when problems happen, because we all know that problems will arise, but you need to respond quickly and efficiently to those problems. Today you will meet, of course, myself from the utility team, also my colleague David Sanchez, but I would like to remind everyone here that GoodWe utility team is composed of a team of more than 10 professionals, and the success of GoodWe last year in the utility segment, it's all thanks to them. Last but not least, the third pillar of success, in my opinion, is the ecosystem. Because, as you know, there are many parties involved in the success of the project, of the execution and the development, namely the owner or the IPP, the EPC contractor, companies, technical advisor, the banks, other suppliers, and so on. So it's very important to know which role each of these companies play in the project and what are their expectations. Because it just takes one unsatisfied person within those companies to put the relationship at risk. And in the end, the whole success of the project. While this seems obvious, what I'm going to say, but the company, there are people working in those companies. You're not working directly with the company. You're working with real people. So it's very important to know their responsibilities and priorities. So for the business relationship to work, is very important to meet each other's expectations, not only at the corporate level, but also at the interpersonal level. So it's very important to understand the needs of the employees of every company. So this is what we do. When we talk to companies, we like to know which are the interest or responsibilities of the persons in each company, and try to make a tailor-made approach to those customers. So to conclude my presentation, I would like to mention that these three pillars of success that I've been mentioning will be present in today's event. First of all, because we will see a presentation of the product and the company. You will also get to meet part of the utility team. And also, and thanks to you, the ecosystem, and this is what you are helping us to develop. This is where we meet to talk and to share ideas and to actually share what makes us passionate, to all of us here, which is the renewable and the PV energy in global. So once again, I would like to thank all the speakers and participants, and wish you all have a good time in today's event. Thank you very much, and have a good day.
Thank you, Alvaro, for that introduction today. Well said. We will see Alvaro later again in the second part of our program for our panel discussion. And now our first presentation of the day will come from Ryan Alexander, research lead for European power markets at Aurora Energy Research. Ryan and his team at Aurora undertake pan-European analysis for national power market teams and develop client-facing subscription analytics products. He oversees analytics and advisory work on onshore renewables, power purchase agreements, offshore wind, utility-scale batteries, and the European emissions trading scheme. Today, Ryan will provide us with insights into macro trends in European solar PV investment. Without further ado, the floor is yours, Ryan.
Great. Thanks so much, Maria. So hello, everyone. Nice to be here and to have this time with you all. As so Maria's already introduced myself, I'm Ryan Alexander, heading up our pan-European power markets team at Aurora Energy Research. So what I do want to do, as Maria mentioned, is provide a bit of a big picture overview regarding policy trends in the solar PV area in Europe. And I also want to then take you through some of the revenue side of the equation for projects. That is an important context for the discussion that we'll all be having later on regarding inverters and string inverters. I think what I'd like to do here is start off by explaining a little bit from the perspective of an IPP, what the revenue side of things looks like and how that influences the decisions and developments that need to take place on the cost side of the equation. So just to also outline, for those of you who don't know Aurora Energy Research, so we're based in Oxford in the UK. We have offices now across the US, Europe, and Australia, and also soon to be Japan. What is our bread and butter? We do power market modeling, we do price forecasting, and this is what forms the basis for the analytics that we provide to our clients across those markets. So let me jump into it. How do things look in Europe? In the European policy environment for solar PV. I'll take us through the Repower EU targets and the implications for build-out rates. Also touch on developments or the takeaways of the recently announced EU solar energy strategy, and then move on to just touch on the revenue models for solar PV across different markets, and finally share with you a snapshot of some of the results of our modeling. So in coming to the first step, or the first point of this presentation. So the European Commission, as many of you are probably aware, particularly in light of the Russian invasion of Ukraine, proposed to increase the EU renewables target even beyond what was initially proposed a couple of years ago. So on the top left side of the screen, you can see there the current installed capacity of variable renewables. So this is solar, wind, and other variable renewables, and also hydro and other renewables. So that's sitting at about 570 gigawatts at the moment. And the Fit for 55 package that was announced a couple of years ago set a target of just over 1,000 gigawatts. The Commission, since the invasion of Ukraine, it has increased that by a further 170 gigawatts. So the ambition is continually increasing over time. That's expressed both in terms of renewable capacities. It's also expressed in terms of the renewable share of final energy consumption, where that target has also increased from 40% to 45%. Now, it's all very well and good to set a target, but what does that mean for deployment? So you can see on the right-hand side of the screen there, historical deployment rates split by solar and wind across the EU. And you can also see a projection of what is going to be required from now onwards to be able to hit those targets. So the 2022 figure you see there, which is sitting at around about 56 or 57 gigawatts at early estimates, is a significant improvement on last year. And the big takeaway there is that solar has been a big driver of that improvement. So if you compare that 2022 figure to the 2021 figure, certainly wind deployment has increased as well, but solar has seen a significant increase since prior year. Having said that, this is not enough. You can see here what's required to be built out over the coming years, and it still necessitates an increase in capacity additions, both from solar and wind. So the policy tailwinds are very much there. And what is holding us back? Well, we all know the different barriers to deployment of renewables. I think it's safe to say that there's still a significant effort required for us to reach those build-out rates that will align with the European Commission's goals over the coming years, to 2030 rather. Now, the Commission, to be able to respond to this challenge, the Commission is doing many things, and member states are doing many things, as well as non-EU states such as Great Britain. What has the EU done recently? The EU, it published a solar energy strategy, which it proposes is a comprehensive vision to rapidly deploy solar energy. Now, there's quite a lot of text on this screen, and I'm not going to go through all of it, but I just want to highlight a couple of things that have come out of this that are very much relevant in terms of tailwinds for the industry. So the European Solar Rooftops Initiative, this is on the left-hand panel of the page. It has some very interesting and I would say potentially impressive targets there, particularly in terms of new buildings, which is something that's relevant for the smaller scale end of the market. But this is something which we haven't seen before. So, for example, all new public and commercial buildings to have solar panels by 2026, all existing public and commercial buildings by 2027, and all new residential buildings by 2029. So, if this is implemented in full and transposed at the member state level in full, this would be a pretty significant shift in deployment of that scale of solar across the EU. There's also a focus on faster and simpler permitting procedures. The Commission has adopted some clearer timelines, shortening the timelines that should be taken for permitting of particularly utility scale solar. Now, what you don't see here is how what these timelines are and how they're going to be transposed into individual member state legislation. The devil is always in the details, so we'll have to see what's happening there. But we've already seen draft legislation in a number of markets across the EU. For example, in Italy, which is suggesting that member states are taking this seriously and will be implementing concrete actions to back this up. Then there's more to say on the implications for the workforce and also research and development in upstream, but I won't touch on those in detail now. So just to say, there's a lot happening at the policy level. Now, what does it mean at the market level, and what does it mean for revenue models? Let me take you through those points. Now, the first thing to point out, I think most of you who are familiar with are in the industry, clearly, that what's driving the majority of build out in Europe, often it's a government support scheme. Now, I think this section I would summarize as really what are the routes to market for solar assets. In most cases, they are government support schemes. So on this slide, what you can see on the left-hand side of the screen is just simple color coding of the kinds of support schemes that are in place across Europe. So in the orange, you have markets which are effectively subsidy-free markets. So the Nordics are the best examples of that, and that is evidenced by the significant amount of particularly wind build out in those markets. In the blue, what you have is kind of the opposite end of the spectrum, where you have two-sided contracts for difference, CFDs, which effectively cap the upside, but also cap the downside for utility scale investments, and they're quite prominent across Europe. In the middle, and in the sort of yellow or orange, what you have are one-sided CFD schemes or CFDs with merchant exposure. What does that mean? It effectively means that you will be capped in terms of a downside risk of prices going lower than you expect, but you will be able to somehow see the benefit of the upside. Now, this is what things used to look like. Now, the important point to take away here is that there is a discussion happening on European power market reform. The European Commission has launched a consultation last month to look at options to avoid or mitigate the risk of volatility in power markets across Europe. And they're going to come out with a proposal to effectively propose reforms to the markets and within Europe. And that's going to come out within a couple of weeks' time. What is likely to happen, at least in our view, based on our discussions and analysis to date, is that there'll be a greater emphasis on CFDs. And if these are rolled out, or if these are promoted or even mandated as the scheme across Europe, then what you'll see is there's less opportunity for upside in those markets where you as a solar developer can currently get that. So you can see on the map there markets like Poland, like Germany, Netherlands, Belgium, Spain, Portugal. These are markets which are potentially where, as a developer, the potential for upside might be reduced depending on how the European Union's proposal goes. Now, that's going to place more pressure on business cases. It also then places more pressure on the cost side of things. And so I think it's an important element to keep in mind that in some of those markets, there will be an increased need to look for cost efficiencies, even more than everyone currently needs to do, because the opportunity for upside on the revenue side of the equation may be either reduced or eliminated entirely. So something to watch. The next point I want to highlight is on the PPA side of things. So on this screen, what you can see is our analysis of PPA demand in Europe out to 2030 on the left-hand side of the screen. And on the right-hand side, the demand by country, but importantly, whether we believe the market is oversupplied or undersupplied in terms of power purchase agreements. Why PPA is important? They are an alternative route to market or a complementary route to market for solar assets. There are different reasons that developers may or may not want to go and secure a PPA. Particularly, well, the past year has been somewhat turbulent in terms of PPAs, but they're not going away. They are a clear route to market. Now, what I would like you to take away from this slide is one thing, that the PPA demand is going to continue to increase and increase substantially. So we're talking about something like over 300% increase compared to present day levels, more or less. And that's a mix of demand from corporates and utilities. And interestingly enough, as electrolyzers start to be rolled out, as investment starts to pour into the hydrogen space, we will see an increasing demand from electrolyzers for PPAs, which is going to present a material, a non-negligible amount of the overall demand for PPAs in Europe. The other thing I would ask you to take away from this slide is to look at the oversupply and undersupply, because in those markets where the PPA market is oversupplied, so lots of developers looking to land a PPA and not so many off-takers, then this places a lot of downwards pressure on the price that a developer can secure for a PPA. Conversely, in an undersupplied market, we would see that developers have the upper hand, so to speak, and there's more off-takers searching around for one of those deals, placing upwards pressure on price. So certainly in those markets which are oversupplied, this places increasing pressure on developers. Now, that's the second last thing I'd like to leave you with. What I'd like to now show you is just a snapshot of what we see, where we see the revenue forecast looking like for power prices across Europe, and in particular, how solar compares to the baseload. So on this slide, you can see very simply on the left, broadly speaking, where countries sit in our forecast in terms of the average baseload price. It's lower in the Nordics, given the prevalence of low-cost hydro. It is somewhere between the 60 and 80 euro a megawatt hour range over that forecast horizon in a lot of Western Central Europe, and it's higher in Southeastern Europe due to the current high levels of thermal generation. What you do see on the right-hand side is the solar capture price, at least an indication of it in relative terms across the markets that we model in Europe. Now, this is effectively the generation weighted average for solar. What is interesting is for sure that, well, we all know that there is a discount to the baseload price for solar generation. And you can see there's quite a few differences, too many differences to go into here, but just it does show you in stark contrast where in some markets you have, for example, GB, lower discounts, which is partly because of a different correlation of solar power across the market, but also because there are increasingly sources of flexible demand, like electric vehicles, that can soak up more of that daytime peak. The thing to take away from this, though, I think, from my perspective, is that capture prices for solar will continue to decrease, and this is going to promote and encourage, incentivize innovation in the solar space. I know that solar trackers are not the focus of the topic today, of a conversation today, but this just goes to show that as the revenue side of the market changes, it's also going to start to, it's continually influencing the cost side of the market, and it's interesting to see how that's going to play out. So with that, I paint a bit of a picture of the revenue side of things from a solar, particularly focusing on solar. All I would like to do there is just highlight that we have analysis on the solar market across Europe, and a report coming out benchmarking those markets to support developers and other players in the market with market entry and pre-feasibility activities, as well as all of the country level forecasts that we do. So if you have any questions, I'll be very happy to hear from you later. Drop me a message. Otherwise, I wish you a good rest of the discussion. I'll be there at the panel at the end and looking forward to the rest of today's session. So thanks very much.
Thank you very much, Ryan. Great to have this level of insight on the EU markets there. And yes, please do keep your questions coming in. Ryan will join us again in the Q&A session a little later in today's program. Next up, though, we shift a little from the inverter to the module supplier's point of view, and welcome Peijun Shen, Senior Manager for Product Marketing at LONGi Solar. Dr. Shen has worked in the solar industry since 2010, I think, in roles from research scientist to product manager. He joined LONGi in October 2022 and is with us today to share his thoughts on module technology trends and on best practice to ensure the lowest LCOE at project level. Peijun, a warm welcome to you, and over to you. Thanks.
Thank you. Thanks, Mark. So let's start. And I'm not sure everyone knows LONGi, but before I introduce our solution, I will discussing about the history of the development of the company. So at the beginning, LONGi is founded as the wafer manufacturer. And so there is some milestone for the company in the 2005. The LONGi became the largest wafer supplier globally, and then around the year of the 2014, the company switched strategy to start to manufacture the cells, solar cells, and the modules. And after that, with the development around 3 and 4 years, and the LONGi became the largest module supplier globally. And then with a lot of the intensive investment on R&D, we also break a lot of the world records on the solar cells and the other everything for others. So in the 2021, you will see we are the largest supplier for the wafers and at the same time for the modules globally. So the wafer shipment is over 70 gigawatts, and for the module, it's around 40 gigawatts. And so behind the reason why we can grow so fast and we can supply the best product on the market, I think personally the wafer and also the cell and the module are all important. So it's more like you can imagine like a sandwich supplier. The wafer is the meat, and the cells processing and also technology more like the baked bread. So we have the best meat, we have the best bread, then we get the best module product for the market. And now from the last year, we are also promote new technologies on the market, including like the hydrogens and also for the new technology on the modules like the IBC, our HPBC, we call it, and I will introduce today. So first of all, let me introduce how we think about the best practice for the utility. So here is in the left is how the investor, they are concerned. So for the PV plant, for the investor, first of all, of course, the capex is what they were concerned, because that means their client, they will invest a lot of money for the PV plant. And after that, their box were running like the 30 years. So the OPEX is important. Then the client, they will have to get the money from the market, like the PPA and or like on the open market. So the yield of the plant also important. So finally, we think for the clients, first of all, the cost, the capital cost is important, and the operation cost is important, yield is important. So finally, you will get like LCOE as the index to judge whether this is the best solutions for their clients. And in the whole PV plant, the module is most important, one of the most important part, because it takes around half cost of the equipments. So first of all, the module cost, the client they were concerned, and also the performance, and the last is the reliability, because if something happens, even very cheap product, and the client can make money from the PV plant. So that we think it's quite important. And also, when we're discussing about the module costs, most of the time we will think the cost of the module, but we selling the power. That means we selling the module per watt, not per module. So the efficiency of the module is critical for the cost, because it can balance and share the cost of the all materials of the module if with the higher efficiency. And at the same time, for the clients, we think it's a quite beautiful thing for the higher efficiency module is it can also the BOS cost from the high efficiency module. Here is an example, like we are supply the average power of the module around 540 plus watts. If we can supply the high efficiency module and to the 560 watts, and then you will see the result. The clients, they can save around half cents per watt of the BOS cost from the higher efficiency of the module. So that's why we think for the clients, the cost important, and the efficiency, it can help them to levelize the cost of the module and also the BOS. And another beautiful thing is we think regularly the high efficiency module will perform better. Right? That means the yield will be higher. So because of it, in the past years, we developed a lot of the module efficiency and yield, of course. So first of all, we developed bifacial PERC. That's the product introduced by LONGi in industry many years ago, based on the PERC technology and the bifacial. boost the yield for the customer, and also like the smart soldering, and it not only improve the module efficiency, but also increase the mechanical loading performance of the module to increase the reliability of the module. And also we optimize the cell size. That's meaning the wafer size. So here is the example. You will see we find the best for the efficiency, the best cell size were around 180. So that's why we standardize the wafer size, because we think for the customer it will be the best solution. And like the half cut technology can also help the performance, like the 2% of the performance from the half cut. And then on the wafer level, we are as I said, we're the largest wafer supply globally, and we invest a lot of the money on the technologies. So around years ago, we switched the boron doping of the wafer to the gallium doping. So that not only improved the degradation performance of module, but also help improve the module performance under the higher temperature. So it's a very beautiful technologies. And for the quality of the wafer, we not only drop down the cost. You will see, if you see the cost in the past years, the cost almost only less than 20% of the cost on wafers now. And at the same time, we improve the wafer quality, like decrease the oxygen content of the wafer, and also improve the minority carrier lifetime, which also will improve the performance module efficiency of a module. And then you will see the result. In these years, we drive up the efficiency of the module, and also at the same time, we optimize the wafer size, the module size, and promote the best performance and best optimize the module on the market. And then not only about the efficiency and also performance module, another very critical thing for the clients is the reliability and the lifetime of the module for the clients. The reason is you will see here. First of all, if something bad thing happened on the module, that means there are a lot of the business module for the clients cannot be achieved anymore. And so you have to rely on your business on the very reliable products. And at the same time, if you can decrease the degradation of the module and extend the lifetime of the module, you will see you can get over almost 20% of the additional yield from your PV plant. That means that you can get more revenues from PV plant. So that's the reason when we think about the module, when we design the module, we not only think about the cost, we think the performance reliability is even higher priority than the cost. So for instance, we are trying like the transparent backsheet, but after testing, we cancel it. It's not a good solution for us because the reliability is not as good as the double glass modules. And also we think about the current issue and for the modules, and we keep the margin of the current for the modules. You will see there is because for the module, the diode is very critical and they're also very sensitive to for the whole lifetime. So you have to keep the current margin, otherwise it's very sensitive to the environment and everything. So we decide to stick the side of the cells to keep the current of the 14 amps, not higher. And at the same time, the mechanical loads, that's why we standardize the wafer size, we standardize our module size. The reason is we know the larger module will be cheaper, but if you think about the mechanical load and the risk of the customer, and after testing, a lot of testing, we give up the larger module. It's not reasonable for the clients on the view of the reliabilities. And so, as I mentioned, we established a lot of the reliability assessment method internally, and some tester is even higher, much higher requirements than the standards. And with that, we based on that, we decide what kind of module, what kind of products we will deliver to our clients. And because of the so high request quality control, you will see the results of the third-party testing. For instance, the RETC test in the past 4 years, we are the top supplier for modules on the reliability, on the quality, and also on performance of the modules. And at the same time, like the PVES test. And you will see we're in the past 6 years, we are all the top suppliers on market for the reliability of our products. And besides about the products, we are also thinking about the future for our clients. That's why we invest a lot on the technologies. So we create a lot of the world records of the sales in recent, and in last year, end of last year, we announced the highest efficiency. That's the world record efficiency on the silicon sales. It's the 26.81% of the efficiencies. And also, we switched the new technologies to our products. That's why also around the end of the last year, we introduced the new product. We call it HPBC. It's the IBC technology, backside contact technology, and the average efficiency of the stair, you will see it will be over 20%, 25% of the efficiency, and the performance on the view of the module efficiency, the irradiation performance, low irradiation performance, temperature performance, and the light absorption for everything. This module, this product is much better than the old technologies. And so what we are launched in the end of the last year is the HymoSex, and not only the performance but also the view. If you see static view, and it's very beautiful products. And finally, I will very short introduce our roadmaps. So this is our technology. We will keep invest on it. The product and for everything to lower the costs of the product. But because the technology is very mature now, so it have the limitation on efficiency. So that the original one is the HymoSex module, and you will see we will promote the new high efficiency in the near future. And at the same time, very soon we will launch a new product that's based on the N-type wafer, and it can balance like performance, cost, balance everything. So we think it will be especially for the south of the Europe, this will be the best choice for the clients. So that's the presentation of today. And if you have any question, it's welcome. Thank you.
Thank you very much, Patron Shen of LONGi. Great to have your insights into module technology there. We are running a little over time. I will squeeze one quick question in for you now. A couple of people in our audience have asked, since you mentioned about the need for longer module lifetimes, how do you verify this at LONGi? What sort of accelerated testing can you use to prove that something will last 25 years, 30 years, or even longer?
Okay, so first of all, I have to say we internally we established a way of evaluate the lifetime, and so like I will say PCT 48 testing. That's the like the aging testing internal, and also a lot of the testing can evaluate the lifetime. But finally, as I said, this is the lab testing. And the 30 years warranty or lifetime is based on the experience in the past and the testing. So combine all these results, we have a confidence our module can service at least 30 years.
Okay, great. Well, yeah, thanks very much for your answer as well. And now I will pass back to Maria.
And Laundry Solar. And joining us next for our final presentation of the day is David Sanchez, EMEA Sales Director for Utility and Large-Scale Projects at GoodWe. David has been in the solar industry for more than 15 years, and during that time he has gained extensive international experience with PV projects. His expertise lies in string and central inverter technologies, and particularly in how string inverter technology can help to maximize the performance of utility-scale solar farm, achieve a lower LCOE and better return on investment. And he's here to share some of his knowledge with us today. David, the floor is yours.
Thank you very much, Maria. Thank you very much, Mark. And first off, welcome everybody to the Good Week. So I hope you're enjoying so far. Yeah, thank you very much. PV Magazine is just a pleasure to actually host this webinar alongside you guys. Thank you very much to all our attendees, and thank you so very much to our speakers. We have very top speakers today, so yeah, it's a pleasure for us. All right, so we have an exciting topic today, right? So inverter trends, LCOE. We have different solutions in the market these days, right? So inverters going bigger, different proposal, different value proposition, right? So I think it's very interesting to actually go through a little bit of GoodWe solution and what is our view as to having a product that actually achieves the lower LCOE possible. I will try to expedite a little bit so we can have time to have our beautiful panel in the end. But yeah, let's go for it. So first off, just a little bit about GoodWe's introduction. Needless to introduce GoodWe at this point, but just a little bit for our audience. So GoodWe is a Chinese supplier, okay, based in Suzhou, which is 1 hour off Shanghai. Our headquarters for EMEA are based in Munich, right? And probably some figures around GoodWe, more than 4,000 employees, more than 800 staff only dedicated to our solar business, right? And more than 150 actually right now. I think we are close to 200 overseas employees, right? So actually GoodWe is the inverter manufacturer that is growing the most. And as Alvaro was saying previously, it's not for no reason. In the end, it comes from a very bankable company, a very good team, a very good product, and the confidence that our customers actually place on us, right? So as I said, GoodWe is actually listed in the Shanghai Stock Exchange. Okay, so all the figures are fully transparent. And we do have an 11% of R&D investment. So 11% of our revenue goes directly to R&D, right? And as of today, we are the inverter manufacturer with the highest figure in terms of investment in R&D. And this is so very important, right? Because investment in R&D leads to higher quality of the product. Higher quality of the product leads to a higher level of innovations, of digitalization, right? And especially leads to a lower failure rate, right? Which is the most important thing about string inverters, right? This is how string inverters manage to deliver lower LCOE through a very high digital and high quality string inverter, right? This is where GoodWe is placed at this moment. Global presence for sure. So we understand the growth in that way, having the local support, the local presence. We open subsidiaries basically globally throughout the main markets, right? For sure, in Europe, in Australia, in the States, in Latin America, in Southeast Asia. So again, we are the inverter manufacturer that is growing faster and the most, right? And also this translates also in our local presence. As I said, we understand that this is very important when it comes to giving the proper support to our customers. This extremely important. As I said, part of the success of GoodWe is the fact that we are being highlighted as the inverter brand with the best bankability in the market, period, right? And this is not only us sales guy actually saying this about GoodWe. It's actually Bloomberg who actually said that in the 2021 report, right? Highlighting GoodWe and only GoodWe as the most bankable inverter supplier globally, right? So please keep that in mind. Again, it's not GoodWe who says that, but it's Bloomberg who is highlighting GoodWe's bankability. And yes, bankability refers to financials, but not only financials. Bankability also refers to the way the company is actually operated, to the sustainability, short, mid, and long term, right? And this is where we are so happy and so proud to be highlighted by Bloomberg as the most bankable inverter supplier globally. Also, this is quite interesting, right? Because probably every sales guy that you guys meet will tell you that his brand is the best and the highest quality, right? Fair enough. But the good thing is that GoodWe, throughout the last years, we actually had independent third party pointing out GoodWe and saying, hey, these guys, they do have a great design. They do have a great R&D investment. They do have a great product, right? So people like EuroPD Research, like Tuve Raylan, and as I said, Bloomberg last year, are all highlighting GoodWe as the top quality supplier that we are, right? And again, it's not for no reason that these days everybody's talking about GoodWe in the market, and we are achieving that massive of a success. Let's go to main thing, solution, right? So again, we want to talk about trends. We want to talk about LCOE. Let's go for it, and let's see how the solution looks like, right? So as I said, our product is a high quality and fully digital string inverter, right? So strings to connect directly to the inverter connects directly to the transformer station. You can actually use power line communication. You can actually use RS-485, right? Then you will have in every transformer station our SCU, okay, our communication box. That will be connected in every transformer station, and then you will have the optical fiber ring between all communication boxes, right? So quite straightforward, quite digital, and as I said, simple, right? Which is one of the main things that string inverters is bringing to the market. And let's talk about LCOE. So first off, LCOE. What are the main factors that do impact LCOE? CapEx, OpEx, and generation, right? So I would say that is fairly acknowledged and assumed by the market that string inverters do deliver a lower BOS and lower O&M compared to central solutions, right? But now it's interesting also to understand how different solutions of the string inverters can actually compare with, right? So, but the most important thing when it comes to LCOE these days, and especially Ryan was mentioning, we see that the PPAs globally are going up, right, due to the global situation, cost, etc., etc. So the more generation means the better money for the customer in their pocket. More money means better return of investment and means everybody's happier, right? So this is why this is the cornerstone of the LCOE reduction by string inverters, the generation, right? The generation is the most important thing. And how can we achieve the maximum generation? Spoiler alert, using our GoodWe 250 kilowatt inverter, right? So jokes apart. So this is our main machine, right? And this is so interesting, right? And Alvaro and the speakers will talk about this in a few minutes, right? But there are different solutions these days in the market, right? And the reality is that we see a massive part of the market that is actually in love with 250 kilowatt inverter, and they don't want to go bigger than that. They understand that there are availability benefits, that there are generation benefits, that there are cabling benefits, right? So this is very interesting, and that is why it's so exciting the market these days, right? Because there are different solutions, there are different value propositions, and there is different opinions within the market, right? Within developers, within technical consultants, within EPCs, right? But as I said, our 250 HT inverter, right? 2 strings per MPPT, 3 strings per MPPT, depending if you are using the 15 or the 20 amps per string version, right? So IP66, PLC, supports up to 400 square millimeter cable, PID solutions through anti-PID and PID recovery, IV curve diagnosis, and string level monitoring, right? So the 2 versions, okay, K version, 250K version, 250KM version, okay? What is the difference? The difference is that if you're using modules with more than 15 amps current per string, then probably you need to go to the KM version, okay? That allows up to 20 strings. If you are using a non-high current module, less than 15 strings, that you go with the K version, right? But again, this is just a general rule, because then what happens if you have 15.5, right? It's important to understand what inverter will do. There isn't a smart algorithm, right, inside inverter. So again, any inquiry, any doubt that you have as to the design with our inverters, please feel free to contact our team. We'll be more than happy to guide you through the best solution possible for your design, right? And very important to highlight that our KM version with 3 strings per MPPT does not need fuses, right? Because it includes what is called a DC switch, an intelligent DC switch, right? That will comply with IEC without the needs of having fuses on site. But let's go to the main thing. This is the main thing, the multi-MPPT topology. This is what actually is bringing string inverters as the total leader in the market when it comes to utility scale project, right? Only a few markets globally, mainly Australia, probably the United States and Israel, are still more like pro-central, right? But the rest of the markets are still dominated by string inverters, right? And this is why it's so important that string inverters keep with that philosophy: the maximum possible amount of MPPTs per inverter, the minimum possible amount of strings per MPPT. Okay, let me say again. Only string inverters can actually be faithful to the concept and actually deliver the best performance possible if they have the maximum amount possible of MPPT and the lower possible amount of strings per MPPT. Why? Because in the end, it's not the same. It's not the same having, especially when we're talking about bifacial, right? It's not the same having 10 strings per MPPT, having 400 strings per MPPT, having 5 strings per MPPT, or having only 2 strings per MPPT. The reality is that you can only take the most out of the bifacial modules if you have only 2 strings per MPPT, right? So that is why it's so important. That is why the multi-MPPT topology is making the difference when it comes to actually maximizing the yield and again getting the best possible return of investment. Same as the thermal design. This is one of the most unique benefits that GoodWe solutions bring into the market. So we bring a solution that does not apply any power derating up to 40 degrees. So from -30 to 40 degrees, full power 250 kilowatt. This is unique in the market. This is unique. Other solutions that start derating way earlier, right? So this first off will lead to better CapEx. You don't need to install these extra units when you need to design at 35 or 40 degrees, which will be anything Mediterranean and south, right? But also in terms of LCOE, also in terms of O&M, right? So again, this is a massive feature. This is one of the most important value differentiation that we are bringing to the market because it's unique, because only we have it, and actually customers are loving it because they see the benefits, as I said, O&M, CapEx, and yield, and therefore LCOE. Overall solution communication, as I said, it's quite straightforward, right? So all the inverters will communicate with SCU, which is our communication box, through RS-45, through power line communication using the Modbus RTU, right? And from the communication box and to the grid, to the grid, basically you will use Modbus TCP, connecting with the PPC, with the SCADA, etc., etc., etc. So as I said, quite straightforward, quite simple, right? Which again, it leads also to BOS saving when it comes to communication cable, etc., etc. Solutions against PID. So we know very well PID is a problem. We know very well most of the module suppliers are doing really a big effort to try to minimize and to guarantee a PID-free solution, right? But it's also important that us suppliers, we actually try to bring solutions and again, some value proposition to actually try to lower the LCOE and try to have the best possible performance on site, right? So this is where we are bringing 2 solutions, anti-PID and PID recovery, right? Because we see that there's different part of the market who actually prefers either one or the other. In the end, the difference will be that one will be running through the night and through the day. The other will be working only through the night, right? But again, different solution to accommodate different needs. The same as the IV curve diagnosis, right? Scan and diagnosis. So this is actually changing the market, right? Because the traditional way of actually going on site with the machine and get a rough idea on what is happening, this is totally over, right? Because you will have a digital tool from your phone. You can actually run the IV curve diagnosis of any single solar farm and actually get with a 99.5 accuracy what is happening there, right? Why? Because inverters have a string level monitoring, because inverter can actually, because they have capacitors and resistors, can actually vary the V and I curves, right? And can actually overlap both patterns, the theoretical and the real one, and can understand what is happening. Is there a diode broken? Is there a glass broken? Etc., etc., right? So again, digitalization smart. Every time we're talking about intelligent, about smart, this is what we are referring to, right? Try to minimize the human presence on site, try to reduce the O&M resources. The same as our platform, our monitored platform for sure. Customers are loving it. You will be able to actually have your string level monitoring using our Solar OS platform. In terms of our transformer station, for sure, we are bringing to the market our transformer station, 20 feet high cube container. Actually, we are already installing the first 40 units throughout Europe as we speak, right? So, and very important to highlight here, 7 MVAs. 7 MVAs is our standard size because we believe that in terms of capex is probably the best size possible, right? Unless you have a very square layout, the reality is that going up beyond 7 MVAs, you might compromise the capex, the cabling, etc., because you will have more units and probably units that are far away, right? So we believe that 7 MVAs is the perfect size for us, and in terms of capex optimization, right? But for sure, it's not our only size. Okay, we have 3.5, and we can actually accommodate your needs. As I said, this is the way it looks. It's a 20 feet high cube container. And finally, just as a final slide, I want to introduce our next series of inverter, 350 kilowatt inverter, right, up to 15 MPPTs. So as I said, so we see that there is a big part of the market that is still in love with the 250 and they don't want to go bigger, right? It's also true that there is another part of the market, probably more with a more capex oriented approach that they see and they want the 300 plus kilowatt inverter, right? So we will also bring by the end of the year the 350 kilowatt inverter. But it's very important to highlight, it will be a 2 strings per MPPT inverter and the maximum possible amount of MPPTs. This is the only way string inverters can actually take the most out of the PV array. And finally, thank you so very much. I hope you find it interesting. Let me just do this logo thing. If you see people doing that on social media, just because they are loving it so much. So yeah, Mark, Maria, back to you guys. Thank you so much. Go to mute, Maria.
Wonderfully informative. That was David Sanchez, EMEA Sales Director for Utility and Large-Scale Projects at GoodWe, and we'll see David again in the final part of today's program, our Q&A session. And up next is our panel discussion, in which we will take a closer look at the LCOE value proposition of different string inverters. I would now like to introduce our panelists and invite them to the stage. You can now turn all your cameras on and give the audience a wave once you're introduced. So Alvaro Zanón, GoodWe's Technical Director for EMEA in the utility and large-scale sector, is back with us. Hi, Alvaro. And here we also welcome representatives of leading European EPCs, Felix Jeter, Team Leader, Power Plant Engineering at BayWa r.e., Nitish Singha, a Project Engineer and Inverter Specialist and Netherlands-based EcoRus, and Alberto Campayo Atienzar, Head of Operations at Spain-based Prosolia Energy. So thank you, gentlemen, for joining us today. So taking a look at 200 kilowatt plus inverters versus 300 kilowatt plus, what are the main advantages and disadvantages in terms of impact on their LCOE? Alvaro, do you mind opening the discussion?
Yes, sure. And I would like to start by saying that, as you saw from David's presentation, that we're going to have a 350 kilowatt inverter. So my opinion here is not biased towards 250 or 350, because otherwise, we would be cannibalizing our products. Yes, we need to talk about LCOE comparison. That's how we usually compare the technologies. So there are a few points to consider in terms of CAPEX and OPEX and yield. In terms of CAPEX, of course, we need to talk about the inverter cost, because in terms of dollar per kilowatt or per watt, a 350 or 300 plus kilowatt inverter will have an advantage. It will be cheaper, let's say. And also, you will have less number of inverters in the field in the end. Now looking at the DC cabling, AC cable, trenches, and so on. In terms of DC cabling, because with the 300 plus kilowatt inverters, the distances of the strings, the length of the strings are longer, then there will be higher cost on the DC cables as compared to a 200 kilowatt plus inverter. But on the other side, on the AC cables, it is true that the 300 plus kilowatt inverters, they have an advantage because they have less cable runs, less trenches. But there is something that is been in the discussion in every group with the larger string inverters, that they are limited to 400 millimeter square cable on the AC side, typically aluminum cable. So this poses a limitation on this regard. Another piece of equipment very important in terms of capacity, transformer. The size in theory can be larger with the 300 kilowatt plus inverter because they will be they can accommodate more inputs, and probably later on we will discuss about the different topologies with inverters in this regard. This is in terms of OPEX and CAPEX. In terms of OPEX, when you have the 200 kilowatt inverter, 200 plus, you will have more units to install and more units to maintain. So that's a disadvantage with those smaller inverters. On the other side, the weight is smaller, so they are easier to install. Still today, we can install the 200 plus kilowatt inverter with 4 people. But if you consider a 350 that has, 10, 20 kilos more, eventually you're going to need some machinery, probably a forklift. And that's something that you need to take into account when you do your maintenance. And also for the construction people, it is difficult to handle 400 millimeter square cable aluminum. So it's another limitation. And just to not extend myself too much, in terms of yield, obviously they need to do a proper comparison. Both inverter technologies need to have the same number of strings per MPPT. If not, either technology will have a disadvantage in terms of yield. Availability is also an important point here because if one bigger inverter fails, then there will be an impact on yield because the availability will be lost. And also remember that replacing one of these big inverters takes longer time because you need a forklift and something like that. And also, finally, if you end up using 400 millimeter square cable, but you cannot limit your AC losses to 1%, let's say, you will have bigger AC losses. And I think I'm going to stop here because I want time for my colleagues to comment on the points as well.
Yes, sure. Thank you, Alvaro. So, Nitish, what's your view on this comparison?
Yeah, well, I think it's a very relevant question with regard to the market trends we are seeing. If we talk of the advantages and disadvantages in terms of the impact on LCOE for the 200s versus 300 kV inverters, let's say, I think we need to probably look into the 3 aspects, which Alvaro already mentioned, being the CAPEX, the OPEX, and the energy production. So with regard to the CAPEX, in my opinion, even though the 300s would generally need less quantity of total inverters, however, from a perspective of fixed DC capacity, due to the limitations of the number of available PV inputs, the inherent DC-AC ratio of the 300s would be lower than the 200s. So this would imply that the total inverter quantity saving for the 300s compared to the 200s would be limited to around, in my opinion, maximum 25% or even less. So, of course, depending on the variant of the 300s you want to consider. So that being said, there is a possibility that the lower price 200s might be able to offset to some degree the quantity advantage of the 300s. The other advantage I see for the 200 is, of course, the cost for DC cabling. The average string length would increase, and we have seen how expensive copper has become in the recent years and the impact it can have on the CAPEX, especially for large plants. There would be, I think, some advantages for the 300s in terms of, let's say, lower cost for inverter racking, the LV connections in the transformers, logistics and handling. However, like the AC cabling would be a very, let's say, an interesting parameter to compare. Due to the lesser total quantity, the 300s would require lesser total AC cable lengths. However, due to higher currents, the 300s need a larger cross-section of the cable. So this might potentially lead to higher volume requirement of the conductor for the 300s, which might take away the advantage of having the lower length, which I mentioned. And additionally, also, as Alvaro mentioned, there is the problem of handling such large cross sections, especially aluminium during the construction. Next, I think in terms of the OPEX, in my opinion, yeah, without, let's say, actual field of failure rate study of the 300s versus 200s, it would be difficult at the moment, let's say, to be conclusive on this aspect. Though the lesser quantity of the 300 should have a positive impact on OPEX in general. But the cost of replacement of 200s versus 300s may potentially also balance it to some extent. Lastly, I think in terms of energy production, yeah, 200s being smaller in size have comparatively less impact on the loss of generation during inverter failures. However, other factors like the ohmic losses, the clipping losses, etc., especially for the high current panels, they need to be considered as well.
Okay, thanks. So you already discussed some of the advantages that 300 kilowatt plus inverters provide, but do these advantages compensate for the disadvantages in general, or is it really a case by case that needs to be studied here? Felix, can we hear from you on this one?
Yeah, sure, absolutely. I mean, the decision needs to be done case by case, but however, from an engineering perspective, I can tell you as more rectangle and the topographic as easy it is, it makes sense to use the bigger inverters, because then you can avoid cable bridges for the DC side and also having less DC cable distance, which makes the 300 kV plus more beneficial. Yeah, unfortunately, the shapes normally in the EMEA regions are not that optimum like we see in other countries. So yeah, it's really a case-by-case decision. And you cannot generalize that the one solution is better like the other. It needs to be analyzed project by project here.
Yeah, definitely. Nitish, you already talked about this. Anything to add? So do the advantages compensate for the disadvantages?
Yep. I think I agree with what Felix mentioned, because we need to do it on a case-to-case basis. Different projects have different topography, the requirements, the design consideration. They are quite different for all the projects. But in general, I think, there are still might be in future many projects where the 200s might still provide a better solution. But of course, it needs to be, let's say, studied on a project-to-project basis.
Yes, so there is no one size fits all. Do you foresee the use of 200 kilowatt plus inverters for sometimes types of PV plants and 300 kilowatt plus for others? So are complicated layouts an obstacle for large string inverters? So can, for example, 300 kilowatt plus inverters be considered for larger PV plants in the order of magnitude from 8 to 10 megawatt? So Alberto, this one goes to you.
Okay, thank you for your answer. And firstly, I would like to appreciate your to allow me to participate in this webinar with these experienced professionals. So regarding your questions, our engineering in Prosolia has done many studies about this topic and the different solutions that the market offers. So to begin with this answer, let me explain why we have done these studies and what Prosolia does. My company is Prosolia is a developer for PV projects and an EPC for industrial self-construction projects, and an IPP company for utility scale. So we are in the many areas of the market. So we care a lot of getting the best LCOE in our projects. So we need to know if our project, the cost effectiveness of our project, if a project is profitable or not. So we study every project in deep to be sure that which is the best solution, and our conclusion could be the following. So if we have a perfect area, when I mean a perfect area, we think a square, when we can get the most optimum project, we don't have problems with the hydrologic studies or topography, as my colleague said, with shapes, high civil works. I mean, when we have a perfect square area, it seems that higher string inverters like 300 kilowatts they are more competitive. Okay, but normally we don't have a perfect area, or it's difficult. So we need to study case by case, because maybe there are projects where we need to install a lower inverter, like 200 or 250, Also, the supplies could be more expensive, but the installation or the location give us a better project. Okay, so for example, in our markets, which are Spain, France, Portugal, and Italy, to find land with perfect areas is being a challenge. So higher every day, and it could be useful for us to have lower inverters. Okay, so however, it's not only in Europe. I mean, I have experience in South and North America, Middle East, Australia, Japan. So I can confirm that developers, EPC, final clients, banks, we appreciate different options and to assure that we have the best solution for the project, especially in this current situation where we have these issues with the global chain supply and suppliers availability.
Okay, thanks. Alvaro, what's your take on this? You're muted. Just turn your mic on, please.
Yes, I just noticed that. Thank you. Yes, actually, Alberto's response was very good. I just want to add probably a couple of points. Of course, I agree what Alberto said, and also Felix before, that the square and rectangular layouts are more suited for smaller string inverters due to the fact that the benefits of these inverters, as we said before, lower cost of the inverter, less number of inverters, less trenches, and so on. They have a higher weight than the disadvantages. So the distances of the AC cable are not a problem, and this makes me think that also larger string inverters are more suited for larger blocks, let's say 8 to 10 megawatts, because they are intended for square blocks. So it is possible to have larger transformer stations. But this is something that, at least in Europe, is very difficult to find. Square blocks, rectangular blocks here are more irregular, stretched, even small islands connected together electrically. So in that case, the smaller string inverters, they have a benefit. But can a larger string inverter still be used for this kind of irregular layouts? Yes, if you are willing to sacrifice some things. For example, if the customer is willing to sacrifice losing some energy yield due to the AC voltage drop because of you're using 400 millimeter square cable, that's fine. You will have 1.5 losses on the AC side, but if the customer is willing to do that, why not? You can do it. And also there are some solutions that probably you can use copper cable on the AC side, which is very expensive. No one would use it. Or you can use some cable cross-section exchange box, meaning that you can enter 400 millimeter square cable and come out with 2 times 240, for example. But again, this is adding on the CapEx side. There are other considerations that need to be taken into account. For example, the PLC distance. For example, in an irregular field, if you use a larger string inverter, you will have very long distances. So the quality of the PLC communications would not be probably good enough. So this is something to consider. Also, the mismatch losses. If you have let's say a very complicated layout like a hilly terrain or an even surface, then you need to consider inverters that have, as David was explaining, 2 strings per MPPT. Also important to evaluate the possibility of mixing inverters of different sizes, let's say in the same plant, 200 and 300. If the supplier has that option, that could be a very good combination of the benefits. Also, the ease of replacement, because as I said before, the 300 kilowatt plus inverter requires a forklift. So if the access is not easy, of course, that would be a problem. So yeah, in conclusion, I think there is a market or a project type for each string inverter, I would say.
Yes, thanks. What we tend to hear more often today is that with the current technology, it seems like 300 kilowatt plus inverters are approaching a size limit that is jeopardizing the traditional advantages of string inverters. Do you agree with this statement? So what needs to be done to continue increasing the output power of string inverters? Felix, this one goes to you.
Okay, I mean, generally, I would say personally, yes, because of the following reasons. If we're speaking about the engineering, I mean, the cabling getting more and more complex on the DC side, but also on the AC side. And I mean, as bigger the inverters gets, the most important is that the number of DC inputs per MPP tracker stays the same. Otherwise, it will not be any more usable. Speaking with the construction guys, I think they are not big fans of the bigger inverter sizes because they need to handle the weight of the inverters on site. But in addition, I don't know if anybody tried to bend a 400 square millimeter or 300 square millimeter aluminum cable if in cold weather. So it's to a certain point just not anymore possible to handle the cabling or the AC cabling of the inverters. And last but not least, the operation maintenance teams, if they want to exchange an inverter with 125 kilograms or more, they need more than 5 people or a forklift. But yeah, that's also not every time available in for the O&M teams and makes the life difficult for them. What needs to be done if the power increase? It needs to be ensured that the number of DC inputs stay the same per MPP tracker. But also, maybe it's additional DC combiner boxes are necessary, which limit then the use of string inverters. And if the string inverters are getting bigger, they're getting central inverters.
Yeah. Okay, Alberto, anything to add to this one?
Yeah, I mean, I agree with Felix's speech, but regarding that statement, I'm not fully agree with that. I mean, my opinion is as the PV models are increasing the power, it seems reasonable that inverters, it doesn't matter if it's string or central, keep going on the same way. I mean, trying to get similar string numbers in the same inverter units. However, on this way, we do not should lose some advantages of the traditional string inverters. I mean, we need to keep, as David said before, I mean, the multiple MPPT is a really great advantage from central inverters, higher efficiency, easy installation and replacement for the O&M team, lower losses. I mean, we need to keep these string advantages, okay? But on the other hand, we need taking care to avoid some problems of these higher inverters. I mean, to increase the weight or the height, as Felix said. For example, we will go to a central inverters, as he said. So, in addition about the cabling, a huge problem. Installation will be more complicated, and we are having some problems in some markets like in Spain or Portugal, where it's difficult to find competitive and experienced installers. So this is going to increase the capex. So we need to find a balance for this. Okay, so how we could increase the output power inverters? Okay, what we need to do is to keep investing in R&D to avoid these problems with the side limit and the height. To check about the current cabling limitation, if we can do some tasks with the cabling. Or check another option as we did in the past, where we increased the 1,000 volts to 1,500 volts. Maybe we need to talk about 2,000 volts in DC side. So conclusion, I do not think that the 300 kVA or higher is the maximum, but we are closer to get in with the current situation of the market. But we cannot forget about the technology in our business, searching the most competitive capex.
Oh, okay, thanks so much, Alberto. And thank you, gentlemen, for this engaging discussion. We now have to move to the next section of today's program, our Q&A. And this is the time when we will forward the questions of the audience to everyone who took part in today's program. So we have a lot of interest coming in. And thank you for putting in the questions already.
Indeed, thanks a lot. We have a whole lot of questions. We won't be able to get through all of them, but we will do as many as we can in the next few minutes that we have left today. So first of all, there's one topic that quite a few have asked about in our audience is inverter lead times. As we know, there have been plenty of supply chain disruptions and shortages lately. So I will direct this first to David from GoodWe. How are lead times and supply chain looking for GoodWe at the moment?
Yeah, thank you, Mark. Yeah, that's the $1 million question, right? So when I can get my inverters, right? So it's probably the question that people are asking the most every single day. So Yes, we know we are going through a tough year, right? So the inverter industry is going through a tough year because of some component shortage, right? So it's something that we need to cope with. So in terms of lead time, so it depends on many things. It depends on the market, it depends on the volume, it depends on so many things, right? So my suggestion would be, guys, just send me a message, send me an email, and we can discuss about your needs any moment, okay? We'll be happy to do so.
Okay, great. Would any of our, well, I think it would be great to hear on this same issue from any of our EPC speakers this afternoon. Would anyone, Felix, perhaps, would you like to weigh in?
I mean, I'm not personally linked to the procurement in our team, so I cannot tell too much about that here. So sorry.
Alberto can say, maybe Alberto can say some insights there.
Yeah, I mean, the global chain supply is a challenge right now. So that's why in my speech I told that it's very important to have options in the market, because we cannot be blocked for some problems in the global supply chain. That's why we need to have several options and many suppliers to be sure that our projects are going to be done on time, because there are a lot of money, many interest involved in the project. So it's one of the biggest challenge that we have for utility scale projects or industrial projects, even self-construction projects. So this is something that we need to take care and to try to find a solution, because this is the key at this moment of the market.
Thank you, Alberto.
Okay, this one goes to Ryan from Aurora Energy Research. What is the weighted average capture price expected for 2030 at the EU level?
So I think it's something that I can't disclose on on the webinar, because we generally tend to provide average prices across a time range when it's something for public digestion. And when we start to go down to annular figures, then usually this is what's included in our off-the-shelf or subscription reports. So the short answer is no, I can't say, but the longer answer is that, as I mentioned in the presentation, what we generally see across the period 2025 to 2040 is in the Western and Central European markets, baseload prices of around 60 to 80 euros a megawatt hour. A bit higher than that in the Southern and Eastern European markets, largely because coal and gas assets are playing more of a role, setting the price more of the time. And then in the Nordic markets, lower than 60 euros a megawatt hour, because of the penetration of lower cost pumped hydro and hydro assets in those markets.
Yeah, thank you for that.
I would actually just add one more point, which is just to say that, you know, the gas price development over the coming years has a big effect, as we probably all know, on power price evolution. And, you know, our expectations regarding Nord Stream, the Nord Stream pipes coming back into operation have diminished over time. And what that means is we'll be reliant more on global LNG flows in the medium term. And this is going to ultimately place some upwards pressure on power prices over that medium-term horizon out to 2030.
Okay, thanks.
And another topic a few of our viewers have asked about is repowering. I think Europe has had a pretty healthy remarket for repowering projects recently. What does this look like for the inverter particularly? Do we see projects switching from central to string inverters sort of midway through their lifetime? I will address this first of all to Nitish.
Yep. Well, yeah, personally, we don't have much experience with repowering of projects. So maybe later on, Alvaro, maybe you have more idea on that. But I do think, while repowering, I think the idea is to have retain as much of the design as possible, right? So I do think the string inverters would still play a vital role even during the repowering phase. But I think, yeah, Alvaro, maybe you can add more content on that topic.
Yeah, and it is actually, I do. We are receiving recently quite a lot of requests for repowering projects, as you said, Mark, changing from central to string. These central inverters are usually quite old. I mean, quite old, meaning 10, 15 years. This is old in the PV industry. The problem with those projects is that the inverter, central inverter operating voltages are not the same as the operating voltages of the current inverters, string or central. So there is a lot of rework to do in terms of cabling. In terms of DC cabling, still can be done on the AC side. Fortunately, it's necessary to buy different transformer stations to accommodate the output voltage. So yes, we're having a lot of requests, but they are not easy to handle because it's a case by case. There are inverters that no longer exist in the market, so finding documentation is relatively difficult as well. What I do see in the coming future, maybe 5-10 years, it's a repowering market for string inverters because there are already in the market string inverters that are working in a 1,500 volt DC and 800 volt AC. This seems to be the trend, and it's not changing in the last 5, maybe 10 years. So maybe it would be possible to repower, let's say, 6 50 kilowatt inverters from 10 years ago, string inverters, with one 300 kilowatt inverter. This still, we haven't seen that, but it's something, a scenario that might happen, I would think.
Okay.
I would add one point here. I think also from a certification perspective, it's not that easy to just exchange from a central inverter to string inverter. So I think that's also a big barrier for doing revamping here.
Mm-hmm. That's correct.
Okay. Thanks. Are weight and space savings ever a concern for inverters in the utilities scale segment? This one is addressed to David.
Yes, of course. So, of course they are. For example, our 250 kilowatt inverters, you don't need a crane, right? Because in the end, the weight that you need to actually manage, it's perfectly for 3 or 2 people to cope with that, right? So, of course, height and weight is a very, very important topic because it will affect the labor cost, it will affect the BOS, etc., let alone the position of the inverter, right? The inverter used to be, or perfect case scenario, inverters are installed underneath the structure, right? But with inverters going bigger and going heavier, this is no longer a possibility, and probably they need to go out in a bar, in a pile, in the main aisle, right? So for sure, it's a thing that there is an evolution there, but it's a very important topic to consider, especially for the EPCs that need to deal with this kind of things on a day-by-day basis. Yeah.
Let me add a couple of points here. Yes, I mean, weight, it's something that needs to be worked on in the coming years with the string inverters, because as we have been discussing, we are approaching the limit where some advantages may be lost due to the size and especially the weight. So there are ways to do it, and it's our responsibility, the inverter supplier, to invest in that. I think it's Alberto who said, well, increasing the voltage to 2,000 volts, even 3,000 volts. I know there are working groups in Europe looking into that. Also, from our perspective, we can look for new components or topologies with new components, let's say the transistors. Right now we're using IGBTs, but we can use other type of transistors. I mean, MOSFET, for example, other type of capacitors like silicon carbide capacitors and different type of inductors. So these components, in theory, can help reduce the size and eventually the weight. Another strategy is to change the topology, but in a way that you split the inverter in two. So you can actually separate the MPPTs and the inverter part in two. So you put the MPPTs on one side next to the array, and the inverter side maybe somewhere else closer to the transformer station. So there are ways to work on that. And I think also what Alberto said, with the current technology, we're a bit getting to the limit. But the technology needs to change. I think that's the key takeaway.
Yeah, definitely. Thanks.
Absolutely. And well, Alvaro, you touched on this in your answer just now, but a lot of people in the audience are asking about the voltage switch. Do we see 2,000, 3,000, even higher on the way in the next few years?
Well,
Oh, go ahead, Alberto.
No, I mean it's an option. It's not something new for the market. I mean, we have done in the past. We started with 600 volts, 1,000. Now we are working with 1,500 volts. So it's something that the market has done in the past. Okay, so that's not it's something that could happen again. But there are a lot of study to do prior to the step. I mean, there's certification, there are legalization, there are many work to do with the utilities and with the certification company. So it's not something that is going to can do in a few months. It's going to something that takes a long. I mean, I remember a few years ago when we did a change from 1,000 volts to 1,500 volts, that it takes a long time. We started in a few countries doing this test, and when we saw that it was an advantage, then all the market changed. So for me, it's an option, but it's something that needs to study carefully, because the industry and the market and everything will change a lot. I mean, it's a 180 degrees of change. So,
and just to add one more point, I know we reached the time. Just one comment. When we switched from 1,000 to 1,500, it was a relatively easy change because it was still considered low voltage. Going above 1,500 on the DC side or 1,000 on the AC side, it's a completely new world. I mean, you're getting into the medium voltage. So completely new regulation, new requirements, new skills for the people. So it's going to take longer. I know it's going to happen. The question is when. And I know discussions have already started, but we'll see.
Yeah, that's also what I want to add, because if you go over the 1,500 volts, you need medium voltage trained people also for the DC side installation. Yeah. And I not know if that's have a positive influence on the LCOE.
Correct.
Mm-hmm. And there is also one saying that a person says, if we increase the voltage in the inverter over 1,500 DC volts, so we are running into problems with installers, since it's not allowed to install this type of technology due to EU laws. Limit is set at 1,500 volts. Is this correct?
This is correct. I mean, this is exactly what we have been discussing. Felix has mentioned the problems with the certification and finding the right people. So yes, that's spot on, that comment.
Yes. So thank you very much, everyone, for taking part in this Q&A. So first of all, thanks to our audience. Thanks everyone for putting in the questions. We didn't get to all of them, but we were just short of time. A special thank you, of course, to Alvaro and David and everyone at GoodWe for initiating this session today. And once more to all of our speakers from Longi, Aurora, Energy Research, Viva, RE, Prosolia, and EcoRus. And of course, to my colleagues here at PV Magazine who helped put together such a great webinar.
Thank you.
Thank
you, guys.
Thank you.